So for this exercise, the objective is to insert trees into our terrain in the spaces that are indicated in the AutoCAD file where there are trees, so the green areas. For this, we also have a base code which has the elements we are going to work with. So I'm going to open that file. And you'll see that the file will have the areas that were indicated in the AutoCAD file as green areas already adapted to the terrain. It will have the 2D limit, the 2D square that we've been working with in the past exercises. And you'll see if I come here and do a zoom on this element, we'll have a mesh for a tree with reduced geometry and ways to not be too heavy to process by the program. This will be the base tree that we'll be working with in this exercise. But so if I zoom in on my other elements again, the first phase of the exercise will be to populate this square with a set of random points. Then after that, we'll project those points onto these areas. And what will happen is that we'll have several points on the green areas where we'll then copy our tree to. And so after that, we're going to copy the tree element, but we're also scaling all the trees randomly between a domain that we are going to create. So the first thing that we are going to do is to populate the square, like I said. So as we did on the first exercise, we're going to do a populate 2D. We're going to connect this region, and we're going to give it a number of points to work. So in this case, for the number of points, we're going to start with 10,000. So we'll have a lot of trees in our terrain. We can also add a seed number, which only serves to change the disposition of the points in the area. It's not obligatory, but take a while, just because it's a big set of points. Maybe for now, I won't add the seed to not take too long. So you see, it's already populating our area with 10,000 random points displayed randomly through the region. So now we're going to project these points onto these areas. So first thing, I'll group these areas. We were in two different layers in the original file. And to make sure that they're all in the same hierarchy, I'm going to do flatten tree. So now we'll project these points. So we'll do project point. We'll project these points now we'll have to say the direction in which we want to project, which will be vertically, so in the Z direction. So I'm going to write Z, and it will give me this unit Z. And the geometry to which we want to project to, which will be the one included in the flattened tree. So you see it has already projected our points onto the areas. So those who were outside the areas were ignored by the program. So now we are going into our tree, and we are going to copy the tree to all these elements. To do that, what we'll do is grab the geometry of our tree, and like we did in the exercise for the terrain, we are going to construct the box which includes the geometry of the tree. And we'll do this to grab the base point for the tree, which will be this one, which will be the point from which we are going to copy the tree to all these projected points. So to do that, I'm going to zoom in on my tree just for you to see what I'm doing. So we are going to construct the bounding box for the tree. Here it is. And now to grab that base face, I'm going to deconstruct the surface of the box into its elements. So its faces, its edges, and its vertices. And now to select the base face, I'm going to do a list item, which is the way to select items in a given group inside Grasshopper. And so, in this case, as I want to select a face, I'm going to connect the F output to my list item. And now to select the specific face that I want, what I can do is either enter more indexes in here or feed it in the I input with a specific number. In this case, I believe it will be the face with the index 4. So I wrote a value 4, and if I connect it to my I input, what I'll see is that the components will select the base face. In your case, it might not be the face with the index equal to 4, it might be another value, but you can use this number slider to select another value and see to which face it corresponds. So in my case, it was the face with the index 4, as you can see here, but it could be with another value. Just it's just a question of changing that value. And now, to get the center point of that area, as we did in the previous exercise, we'll do the area component, because beyond the value of the area, it also gives us the center of the object that we are reading. So we'll get center point. And in this way, we'll have the point from which we are going to move our trees. So now what we're left with is to move this tree element from its center point to all these projected points. As you might remember, how we copy things in Grasshopper is by creating the movement line which we're going to move our element. So I'm going to do a line, or I could do also a vector 2 points. And this line will be between the center point, the base point for the tree, and all my projected points. So you'll see, come here to the projected points, and I zoom in on the projected points. You'll see that it's creating the movement lines between all the projected points and my base tree mesh. So now I'm going to move according to this line. So move. So the line will be the T input, which is the translation movement. And the geometry will be my tree. So I'll come here, I'll move it just a bit upwards, and I'll connect my tree to my move. Let's create a relay here just to move this up. So move the tree element. So now I already have my trees in all my projected points. But as we know, the trees aren't all the same. They vary in size. So we are going to simulate more or less that randomness of the trees. So we are going to create a domain between a set of values from which the trees are going to change in size in our model. So first thing that I'm going to do is to grab the tree element again, and I'm going to grab this length of the canopy of the tree. And what we are going to say to the program is that we want to change these values randomly between the sets of values. For example, I'm going to use between 1.5 and 8 meters. So we'll have trees randomly through our model with canopies between 1.5 meters and 8 meters. So we'll have a lot of variation in our trees. So in order to get the length of the canopies, what we are going to do is to grab the base face, which we have here, base face for our tree, and we are going to deconstruct it to grab the edges of the face and then get the length of those edges. So I'm going to again do a deconstruct grip. I'm going to grab the element which is in my list item, which is the face. And now that I have the edges of the face, I'm going to do a length and connect it to my E output, which is the edges. So now I have the length of my base edges. And so now what I'll create is the random domain factor. So we'll do that by creating a division. We can also create mathematical calculations inside Grasshopper. So I'll do a division, which will allow us to create our factor. So this length will be the B value. And for our A value, we'll create that random domain between 1.5 and 8. So we'll do that first. To create a random domain, we'll create exactly that, a random list. And that list will ask us for a range, which will be our two set values, a number of random values that we want to have. So in this case, it will be the number of trees that we have in our model. So first thing, to create the range, we'll create a domain. So we'll do exactly construct domain. And this domain will be between, as I said, 1.5 and 8 meters in my case. But if you want, you can change these values. If you find that 1.5 is too small for the trees or 8 is too big, you can change these values at your will. It's a question of seeing the final result and deciding from there. But for now, I'll construct the domain between these two values. And this domain will be the range for my random list. And now for the number of values inside my random list, as I said, it's going to be the number of trees that I have. So if I come to my move, what I can do is get the number of elements inside my move. So first thing, I'm going to do flatten tree in order to have all the elements in the same drawer, the same hierarchy. What I'll then do is do a list length, which will give me the number of elements inside a given list, inside a given component. So I'll do a list length and I'll connect it to my flattened tree. This won't show anything. It's just a number and a set of values. But so now I'll connect this list length to my random, to my n input, which will give me the number of values that I'll randomize. And then this random domain that we've created here, it's going to be the other value for our factor. So we'll add to the division. And so now we have the factor to scale our elements. So now it's the last thing that we have to do. So I'm going to zoom in on my trees. And now, final operation will be a scale. And so, for the scale, it asks us for three things: the geometry we want to scale, the center from which we want to scale those elements, and the scaling factor. So the scaling factor will be, obviously, this division that we've created. The geometry will be the trees moved to the terrain, so the ones that are included in our flattened tree. And now the center from which we are going to scale the trees are going to be the insertion points, so the projected points to the terrain, which are the center points for each tree. So I'm going to grab the projected points here. I'm going to grab this and connect it to the center. So what you'll see between the trees that were moved and the scaled trees. So now we have the trees scaled randomly between these points. Again, if you want, you could come to the domain that we constructed and change these values. Okay. But so now we have our trees. Now what we can do is create a layer in Grasshopper to bake our trees to. For example, 3D trees. Now, going back to Grasshopper, I'm going to right-click my scale element, do bake, select the layer that I just created, do OK. And you can see the trees already located in their spots. Now, if I connect my 3D terrain and I put in a rendered view, I have my terrain from the previous exercise now with trees in the areas, in the green areas. And that's it for this exercise.